So welcome. This is the total revision of all the integration for both IBDP and A levels. So the first question. So we will be going to do all the different kind of models of the question based on the topic integration and some past paper questions. So it is given that the first question, y equals to x power 3 upon 2 plus 48 upon x. Find the value of x and the value of y when dy by dx equals to 0. So what has been given? Dy by dx equals to 0. So I find dy upon dx. So x power 3 upon 2 derivative is 3 upon 2 times x power 1 upon 2 plus this was 48 x power negative 1. So it becomes negative 48 x power negative 2. Now dy by dx should be equals to 0. So 3 upon 2 x power 1 upon 2 minus 48 upon x square should be equals to 0. So 3 upon 2 x power 1 upon 2 should be equals to 48 upon x square. Do the cross multiplication, x power 1 upon 2 times x square equals to 48 times 2 upon 3. So which is x power 5 upon 2 equals to 32. So x equals to 32 to the power of 2 upon 5. Do by calculator, it gives you x value as 4. I need to find the value of y2. So y is x power 3 upon 2 plus 48 upon x. But x value is 4. So 4 power 3 upon 2 plus 48 upon x, which is 4, which gives me the value of y is 20. Now show that the value of y which you have found is minimum. So for showing that, what am I supposed to do? Find the second derivative. Dy square upon dx square. So it becomes, this one was the first derivative, then the second derivative. 3 upon 2 times 1 upon 2 x power negative 1 upon 2 plus 48 times 2 times x to the power of negative 3. So it becomes 3 upon 4 square root of x plus 96 upon x cube. Now when I plug in x equals to 4, so I get d square y upon dx square equals to 3 upon 4 root 4 plus 96 upon 4 cube, which is a positive number. So therefore it is minimum value. Next, that has been done. Part C, find by integration the area. So where is part C? Find by integration the area R given in the form of P plus Q ln R for this curve between x equals to 1 and x equals to 4. So I'm going to do the integration part for that. So integral from 1 to 4. 1 to 4 x power 3 upon 2 plus 48 upon x dx. So what is going to be the integral? X power 5 upon 2 upon 5 upon 2 plus 48 ln x from limits 1 to 4. Substitute 4 now. 2 upon 5, 4 power 5 upon 2 plus 48 ln 4 minus 2 upon 5, 1 power 5 upon 2 plus 48 ln 1. So that becomes, when I simplify that, 64 upon 5 plus 48 ln 4 minus 2 upon 5, ln 1 is 0. So what does that becomes? 62 upon 5 plus 48 ln 4. That's going to be the answer. Question number 1. Coming to question number 2. Find the equation of a tangent when t equals to 2. So for finding the equation of a tangent, so first of all I have to find it out, dx upon dt. What is dx upon dt? 60. dy upon dt. What is dy upon dt? 60 square. So what will be dy by dx? dy by dx will be dy upon dt upon dx upon dt. So dy by dt is 60 square upon 60. So it becomes t. So t equals to 2. That's going to be the gradient m. Now the point we need to know. So x equals to 3 times 2 square, which equals to 12. Y equals to 2 times 2 cube, which equals to 16. So the point is 12 comma 16. So I got the point and I got the gradient. So I use the equation y minus y1 equals to m times x minus x1, which further simplification, I am directly writing it out. You will be getting y equals to 2x minus 8. Next, show that the coordinates of q is 3, minus 2. The tangent meets the curve again at q. Show that the coordinates of q is 3, negative 2. So the tangent y equals to 2x minus 8 is the tangent. It meets the curve. So what was y? Y was 2t cube equals to 2 times x. What was x? 3t square minus 8. So I can cancel 2, 2 and 4. So t cube equals to 3t square minus 4. So t cube plus minus 3t square plus 4 equals to 0. This upon factorization, it becomes t minus 2 whole square times t plus 1 equals to 0. This gives me two values of t equals to negative 1, t equals to 2. But t equals to 2 was already p. So t equals to negative 1 will become q. So x equals to 3 times negative 1 whole square, which is 3. Y equals to 2 times negative 1 whole cube, which is negative 2. So 3 comma negative 2 is going to be the value of q. Now, the shaded region R is bounded by the arcs OP and OQ of the curve and the line PQ as shown. Find the area R. So we copy this diagram and go to the next page and try to find it out. So we know that at over here t is 1, t equals to 1, and this distance was x was 12 and the height is 16. So what am I going to do it at? First of all, I'll find the area under the curve. Area under the curve. So integral of from t equals to 0 to 1 y dx upon dt times dt. Whenever the parametric form is given, area will be ay dx upon dt times dt. So in that case, that will become integral 0 to 1 y. What was y? Y is nothing but how much? 2t cube times dx upon dt is 60 dt. So it becomes, it is 0 to 2, not t equals to 1. It was 0 to t equals to 2. 0 to 2 because t was 2 and we got the value of x as 12 and y as 6. So 0 to 2. What does that becomes? 12 t power 4 integral 0 to 2 dt. So 12 t power 5 upon 5 0 to 2. So it becomes 12 times 2 power 5 upon 5, which is 12 times 32 upon 5. 12 times 32. So when I take the calculator and get the value of 12 times 32, so I should be getting it out the answer in the way where in the form of a fraction, because now we are getting only the part below the curve. So 12 times 32 will be giving me 384 upon 5. Now what am I going to do? I don't want that entire region, so I have to subtract this part. The one which is area of a triangle. Area of a triangle is half base times height. Half base. What is this point? This point is going to be the x-intercept for the tangent. So tangent equation was y equals to 2x minus 8. X-intercept. So y equals to 2x minus 8. X-intercept means y equals to 0. 2x minus 8. So x equals to 4. That point is 4. So the base will be 12 minus 4 and the height is 16. So it is 12 minus 4 is 8. 4 times 16, which is 64. So 384 upon 5 minus 64. So I take the calculator. 384 upon 5 minus 64, which gives me 64 upon 5. That is above the x-axis. Now I have to find the area below the x-axis. fall below the x-axis. When we zoom and see that this part is below the curve from t equals to 0 to -1, and what is the extra thing? Area of the triangle. I have to find the area of the triangle. So first of all, I'll find it out, area under the curve. So for that, integral 0 to, what is that? -1. Again, y dx upon dt. Y dx upon dt times dt. So it is 0 to -1. Y is nothing but what? 2t cube. Dx upon dt is 60 and dt. So it becomes 0 to -1, 12 t power 4 dt. So 12 t power 5 upon 5, 0 to -1. So it becomes 12 -1 whole to the power of 5 upon 5 minus 0. So I get it out minus 12 upon 5. The area is negative because it is below the x-axis. So but we will be taking it out as positive. Now one more area of this triangle. How do I find area of a triangle? Half base into height. What was the base? It was 4 minus this t equals to -1. So when t equals to -1, what is going to be the distance, x value? So let me write it out over here. Area of a triangle. I have to find area of a triangle. Half times 4 minus t equals to -1. So x equals to nothing but how much? What was x? X equals to 3t square. 3 times negative square, so which is 3. So 4 minus 3 times height. Height is nothing but what we know. It was -2. So height is nothing but what? -2. So it is -1. So the area is going to be -1. So -12 upon 5, add it out that one, -1. So -17 upon 5. -17 upon 5 means total area is plus 17 upon 5. So my area will be, on the top part it is 64 upon 5, and the bottom part it is 17 upon 5, which is nothing but what? 81 upon 5, which is 16.2. That's going to be the answer. So you have to be very careful because you are finding the area below the curve, it will be negative. So therefore, but while adding it out, we want to find the total area, which is positive. Make the negative area as positive. Now, this graph shows a part of the curve of the equation y equals to f of x, where e power 0.5x plus 1 upon x. The curve has a stationary point at x equals to alpha. Find f prime x. Hence calculate f prime of 1.05, f prime of 1.10, and deduce that alpha lies between 1.05 and 1.10. Find integral, the shaded region bounded by the curve x equals to 2 and x equals to 4 to two places of decimals, the region R. So first, f prime x. What is given? F of x. F of x is given as e to the power of 0.5x plus 1 upon x. So, which is f prime x, not f inverse of x. F prime x is 0.5 e to the power of 0.5x, and 1 upon x derivative will be minus 1 x power -2. Now, what am I going to find? F prime of 1.05. Plug in that one, 0.5 e to the power of 0.5 times 1.05 minus 1 upon 1.05 whole square. So when I find that, I'll be getting negative 0.061, which is less than 0. Then I find f prime of 1.10. So 0.5 e power 0.5 times 1.10 minus 1 upon 1.10 whole square. I'll be getting 0.040, which is positive. So the derivative changes from negative to positive, means the graph is going from negative to positive. So we can say that it has a, what it says, a root at what it says that between that negative value and positive value. So remember that there is a change of sign. If the first derivative changes its sign from negative to positive or positive to negative, it indicates that the root lies between in the interval 1.05 to 1.10. That is part B. Part C, find the integral of f of x. So we have to find it out, integral of this. E to the power of 0.5x plus 1 upon x dx. Integral of e to the power of 5x is e to the power of 0.5x divided by 0.5. 1 upon x integral is ln x plus c. Now we have to find the area. Area means apply the limits. 2 to 4 y dx is going to be the area. So integral 2 to 4 e to the power of 0.5x plus 1 upon x dx. So 2 e to the power of 0.5x plus ln x from the limits 2 to 4. Plug in 4 now. 2 e to the power of 2 plus ln 4 minus 2 e to the power of 1 plus ln. What is that? Ln 2. So what do I get it out from there? 2 e to the power of 2 minus 2 e to the power of 1 plus ln 4 minus ln 2. So when I simplify it out, 2 decimal places 10.03. This is 2 dp. That's going to be the answer. Question number 4. We are going to use the acronym ILATE, integration by parts. I stands for inverse trigonometric functions, L stands for logarithmic function, A stands for algebraic functions, T stands for trigonometric functions, E stands for exponential functions. So my first function is algebra, second function is e power minus x. So first function, integral of second function is minus e power minus x minus derivative of first function, integral of second function. So it becomes minus x e power minus x plus integral of e power negative x dx. So it becomes minus x e power negative x minus e power negative x plus c. Given that y equals to pi by 4 and x equals to 0, solve the differential equation. So we have to do the differential equation solving. So e power x dy by dx equals to x upon sine 2y. What am I going to do? Variable separable. Sine 2y dy equals to integral of x upon e power x dx. Sine 2y integral, negative cos 2y upon 2. X e power minus x is nothing but what? X e to the power of minus x, which is nothing but what? Our part A. What was part A answer? Negative x e power negative x minus e power negative x plus c. Now he has given that y equals to pi by 4, x equals to 0. Y equals pi upon 4, x equals to 0. So plug in that one. So minus 1 upon 2 cos of 2 times pi upon 4 equals to minus pi upon 4 x value was 0, right? So minus 0 minus e power minus 0 plus c. So this becomes 2 times 1, 2 times 2, cos 90 is 0. 0 equals to negative 1 plus c, so c equals to 1. So what will be the equation now becomes? Minus 1 upon 2 cos 2y equals to negative x e power negative x minus negative e power x plus 1. Multiply by minus and multiply by 2 also. So what does it becomes? Cos 2y equals to 2 bracket x e power negative x plus e power negative x minus 1. That's going to be the answer. Next, integral of 1 upon x plus 1. So we have to do the partial fractions for this. 1 upon x times x plus 1 equals to a upon x plus b upon x plus 1. So 1 equals to a times x plus 1 plus b times x. Now plug in x equals to 0. So 1 equals to a. Plug in x equals to negative 1. 1 equals to negative b. b equals to negative 1. So what will be the partial fractions now? The partial fractions will become 1 upon x minus 1 upon x plus 1 dx. What is 1 upon x? Ln x. 1 upon x plus 1 is ln x plus 1 plus c. So what does it becomes? Ln of x upon x plus 1 plus c. This is going to be the answer. Now use the substitution u equals to e power x to a, or otherwise find the integral of 1 upon 1 plus e power x. 1 upon 1 plus e power x dx. So he's asking plug in the substitution u equals to e power x. So du upon dx equals to e power x. So du equals to e power x dx. So do I have e power x dx? I don't have e power x dx. So what can I do? Dx equals to du upon e power x. What is e power x? U. So du upon u. Now plug in that one. What does it become? 1 upon 1 plus u times dx is nothing but what? 1 upon u du. So what does that becomes? 1 upon u times 1 plus u du. Just now we have done it out in part 1. It is ln of x upon x plus 1. Ln of u upon u plus 1 plus c. But what is u? U is e power x. So ln of e power x upon e power x plus 1 plus c. This is going to be the answer. Then use integration by parts to find x square sine x. So part C, integral of x square sine x. So this is the first function and second function. So it becomes first function, integral of second function is negative cos x plus minus integral of derivative of x square is 2x and minus cos x dx. So it becomes negative x square cos x, minus times minus is plus, numbers pull outside, x cos x dx. So again this is first function and second function. So negative x square cos x plus 2 times first function, integral of second function is sine x, minus integral of derivative of first function is 1, integral of second function is sine x dx. So what does that becomes now? Negative x square cos x plus 2x sine x minus 2 integral of sine x is negative cos x plus c. So my final answer is x square cos x plus 2x sine x plus 2 cos x plus c. Coming to question number 6, integral of x sine 2x. First function is x, second function is sine 2x. First function, integral of second function minus cos 2x upon 2 minus integral of derivative of first function 1, integral of second function minus cos 2x upon 2 dx. So it becomes negative 1 upon 2 x cos 2x, minus times minus is plus, 1 by 2 integral of cos 2x dx. So negative 1 upon 2 x cos 2x plus 1 upon 2 cos 2x integral is nothing but what? Sine 2x upon 2 plus c. So what do I get it out? Negative 1 upon 2 x cos 2x plus 1 upon 4 sine 2x plus c. At y equals to 0 and x equals to pi by 4, solve this differential equation. So what is the differential equation? Dy by dx equals to x sine 2x cos square y, variable separable. So 1 upon cos square y dy equals to x sine 2x dx integral. So 1 upon cos square y is secant square y dy. Integral of x sine 2x dx. Secant square y integral is tan y. And this is from part 1, which was minus 1 upon 2 x cos 2x plus 1 upon 4 sine 2x plus c. Now what am I going to do? Plug in y equals to 0 and x equals to pi by 4. So tan 0 equals to minus 1 upon 2 pi by 4 cos 2 times pi by 4 plus 1 upon 4 sine 2 times pi by 4 plus c. Tan 0 is 0 equals to cos pi by 2. Cos pi by 2 is 0 plus sine pi by 2. Sine pi by 2 is 1 and c. So this gives me c value as negative 1 upon 4. So what will be the equation now? Tan y equals to negative 1 upon 2 x cos 2x plus 1 upon 4 sine 2x minus 1 upon 4. Question number 7. A curve has an equation f of x and passes through the point with the coordinates 0, negative 1. Given that f prime x equals to this much, use integration to obtain an expression for f of x. So basically nothing but what f prime x means, dy by dx equals to 1 upon 2 e power 2x minus 6x. So dy equals to, it's just like a integration differential equations. Dy equals to 1 upon 2 e power 2x minus 6x dx. What am I going to do? I am going to apply integral on both sides. So y equals to 1 upon 2 e power 2x integral is e power 2x upon 2 minus 6x integral is 6x square upon 2 plus c. Now he gave that x equals to 0, y equals to negative 1. So plug in that one. So negative 1 equals to 1 upon 4 e power 0 minus 0 plus c. So that gives me the c value as minus 1 minus 1 upon 4, which is negative 5 upon 4. So what will be f of x? F of x will be 1 upon 4 e power 2x minus 3x square minus 5 upon 4. Now show that there is a root for the equation f of f prime x equals to 0, where alpha lies between 1.41 and 1.43. So what am I going to do? I am going to find it out f prime of 1.41. Just plug in 1.41 in f prime, you will be getting it out negative 0.07, which is less than 0. Plug in 1.43 in the f prime, you get positive 0.15. So there is change of sign. There is change of sign. So root lies between 1.41 and 1.43. Now coming to question number 8. F of x equals to 16x power 1 upon 2 minus 2 upon x. Solve f of x equals to 0. Then integral, then between the limits. So f of x equals to 0. 16x power 1 upon 2 minus 2 upon x equals to 0. So 16x power 1 upon 2 equals to 2 upon x. Do the cross multiplication. 16x power 3 upon 2 equals to 2. X power 3 upon 2 equals to 1 upon 8. X equals to 1 upon 8 whole power 2 upon 3. So which is equals to nothing but what? 1 upon 4. Next, in part B, what is he asking? Integral. Integral of f of x. 16x power 1 upon 2 minus 2 upon x dx. So what does that become? 16x power 3 upon 2 upon 3 upon 2 minus 2 ln x plus c, which is 32 upon 3 x power 3 upon 2 minus 2 ln x plus c. Now in the next part, what is he asking? Apply the limits 1 to 4 for that f of x. Means for that answer, we are going to apply the limits. 32 upon 3 x power 3 upon 2 minus 2 ln x from 1 to 4. So plug in 1 to 4, 32 upon 3, 4 power 3 upon 2 minus 2 ln 4 minus 32 upon 3, 1 power 3 upon 2 minus 2 ln 1. So when I simplify that, it becomes 32 upon 3 times 8 minus 2 ln 4 minus 32 upon 3 times 1 plus times minus is plus ln 1 is 0. Simplify that, it becomes 224 upon 3 minus 2 ln 4. That's going to be the answer. Question number 9. He's asking us to find it out this one. So we have to use one formula. What is this? F of x whole power n times f prime x dx will become f of x whole to the power of n plus 1 upon n plus 1 plus c. So which is f of x? So f of x is x square plus 3. F of x is x square plus 3. So let us do by substitution method also, we can do that. So then du by dx equals to 2x. So du equals to 2x dx. Now, what is the question we have? The question we have is x times x square plus 3 whole power 5 dx. So 2 is missing. So multiply and divide by 2. So it becomes 1 upon 2 u power 5. 2x dx is nothing but what? Du. So it becomes 1 upon 2 u power 6 upon 6 plus c. What is 1 upon 12? U is nothing but what? X square plus 3 whole to the power of 6 plus c. Now show that 1 upon x square ln x from 1 to e equals to 1 minus 2 upon e. So let's start a new page there. Part B, integral 1 to e, 1 upon x square means x power negative 2 ln x dx. So isolate, logarithmic is first function, algebra is the second function. So first function, integral of second function, x power negative 1 upon negative 1 minus integral of derivative of first function, integral of second function, dx. Limits later I will be applying it out. So it is minus 1 minus ln x upon x plus integral of x power negative 2 dx. So it becomes minus ln x upon x plus x power negative 1 upon negative 1. Now what am I going to do? Plus c. This is indefinite integral. Now, but the reason is it is a definite integral. So 1 to e x is power negative 2 ln x dx. It will be minus ln x upon x minus 1 upon x, limits 1 to e. Plug in this one, minus ln e upon e minus 1 upon e minus ln 1 upon 1 minus 1 upon 1. So it becomes minus 1 upon e minus 1 upon e minus 0 plus 1. So 1 minus 2 upon e is going to be the answer. Is there any another part in that question? And final part C is also there. This is by partial fractions. We go back and start to do the partial fractions for that. 1 upon x plus 1 times 2x minus 1 equals to a upon x plus 1 plus b upon 2x minus 1. So 1 equals to a times 2x minus 1 plus b times x plus 1. So now x equals to 1 upon 2. When x equals to 1 upon 2, 1 equals to b times 3 upon 2. So b equals to 2 upon 3. Then x equals to negative 1. 1 equals to a times negative 3. So a equals to negative 1 upon 3. So what will be the integration becomes now? Let me start a new page. It becomes integral of 1 to p 2 upon 3 upon 2x minus 1 plus negative 1 upon 3 upon x plus 1 dx. So it becomes 2 upon 3 ln of 2x minus 1 divided by 2 minus 1 upon 3 ln of x plus 1. Total, the limits are 1 to p. So I can take 2 and 2 cancels, 1 upon 3 common. So ln of 2x minus 1 divided by x plus 1. From the limits 1 to p. Now plug in the upper limit, 1 upon 3 ln of 2p minus 1 upon p plus 1 minus ln of 2 minus 1 upon 1 plus 1. So what does that becomes? 1 upon 3 ln of 2p minus 1 upon p plus 1 minus ln of 1 upon 2. So ln minus becomes division. 1 upon 3 ln of 2p minus 1 upon p plus 1 divided by 1 upon 2. So it becomes 1 upon 3 ln of 4p minus 2 upon p plus 1. This is going to be the answer. Question number 10. Again, partial fractions, integral and definite integral. Indefinite integral and definite integral. Partial fractions. So what am I going to do? Part A, 5x square negative 8x plus 1 equals to a times 2a times, because 2 also should be there, 2a times x minus 1 whole square plus b times 2b times x minus 1 plus 2cx. Now what am I going to do? Plug in x equals to 0, so you get it out 1 equals to 2a, so a equals to 1 upon 2. Then plug in x equals to 1, you get negative 2 equals to 2c, c equals to negative 1. Then compare the coefficients of x squared. 5 equals to, over here I get 2a, and over here I will be getting it at 2b. So plug in a as 1 upon 2. So 2b equals to 4, b equals to 2. That's going to be the answer. Now the partial fraction. So what does that becomes now? Integral of f of x dx will be integral of 1 upon 2 upon x plus 2 upon x minus 1 minus 1 upon x minus 1 whole square dx. So it becomes 1 upon 2 ln x plus 2 ln of x minus 1, then minus x minus 1 whole power negative 1 upon negative 1 plus c. Now for this one we have to apply the limits 4 to 9. So it is 1 upon 2 ln x plus 2 ln of x minus 1 plus 1 upon x minus 1 from 4 to 9. Plug in 9, 1 upon 2 ln 9 plus 2 ln 8 plus 1 upon 8 minus ln 1 upon 2 ln 4 plus 2 ln 3 plus 1 upon 3. So it becomes these two are lns and these two are lns. So first of all this becomes ln square root of 9 plus ln 64 minus ln square root of 4 minus ln 9. Then the numbers are 1 upon 8 minus 1 upon 3. So this becomes ln 3 times 64 divided by 2 times 9 plus minus 5 upon 24. 1 upon 8 minus 1 upon 3 is 5 upon 24. So this becomes ln 32 upon 3 minus 5 upon 24. That's going to be the answer. Question number 11. This is again parametric form. Find the gradient. Whenever the parametric form is given, first we have to find dx upon d theta. Phi cos theta. What is phi cos theta derivative? Minus 5 sine theta. Then dy by d theta. What is sine theta derivative? Cos theta. So what is dy by dx? dy by dx will become dy by d theta divided by dx upon d theta. So which is 4 cos theta divided by minus 5 sine theta, which is minus 4 upon 5 cotangent theta. But theta is pi by 4, so the gradient is minus 4 upon 5 cot pi by 4. Cot pi by 4 is 1, so gradient is minus 4 upon 5. Now plug in to get the value of x. X equals to 5 cos pi by 4, so which is 5 upon root 2. Y equals to 4 sine pi by 4, which is 4 upon root 2. So what is the point? 5 upon root 2 comma 4 upon root 2. So then I am going to find the equation of a tangent. Y minus y1 equals to m times x minus x1. So I'm directly writing it out. Y minus 2 root 2 equals to minus 4 upon 5 x minus 5 upon root 2. You can leave it there. Next part, find the coordinates of the point where R meets x-axis. X-axis means y equals to 0. So 0 minus 2 root 2 equals to minus 4 upon 5 times x minus 5 root 2, 5 upon root 2. So minus minus cancels. So 10 root 2 upon 4 equals to x minus 5 upon root 2. So x equals to 5 root 2 upon 2 plus 5 upon root 2. So which is going to be directly, I'm writing it out, 5 root 2. So the point R is 5 root 2 comma 0. Next one, find the area of the shaded region. So we have to find the area of the shaded region. So let us copy this diagram and get this diagram over here. So what am I going to do it out is, I am going to find the area of this triangle and then subtract the area under the curve. Then automatically I'll be getting the area of the shaded region. So that is my plan. What's the plan? Area of triangle minus area under curve. Area of a triangle, half base times height, half base. Now at P we know the value of x. What was the value of x? 5 upon root 2. And height is 4 upon root 2. And R is x-intercept for the, what is this one, which we have found it out, 5 root 2. So base will be 5 root 2 minus 5 upon root 2. And height will be 4 upon root 2. So it will become 1 upon 2, 10 minus 5 upon root 2 times 4 upon root 2. So it becomes 20 upon 4, which is going to be 5. Now I have to find the area under the curve. Area under the curve, what should I be doing it out? Integral, because it is in parametric form, y dx upon d theta times d theta. The limits. What are the limits of x? So theta was, we can see that theta was over here, pi by 4, because we were starting at pi by 4. Theta was pi by 4, and over here what is the value of theta? What is the value of, first of all we have to know that x value is 0. What is x? We know that x value is 0 over there, or y value is 0, because on x-axis y is 0. What is y? 4 sine theta. 4 sine theta equal to 0, so theta equals to 0. So minus integral of pi by 4 to 0 y. Y is 4 sine theta times dx upon d theta minus 5 sine theta d theta. So it becomes plus 20 integral pi by 4 to 0 sine square theta d theta. So plus 20 sine square theta. Sine square theta means 1 minus cos 2 theta upon 2 d theta. So it becomes 5 plus 10, because this 5 continues there, pi by 4 to 0, 1 minus cos 2 theta d theta. So 5 plus 10, 1 integral is theta, cos 2 theta integral is sin 2 theta upon 2, pi by 4 to 0. So 5 plus 10 times, apply the upper limit, 0 minus 0 by 2, sin 0 is 0. Then minus pi by 4, minus sin 2 times pi by 4 is pi by 2 by 2. So 5 plus 10 times minus pi upon 4 plus 1 upon 2. So it becomes 5 plus or 5 minus 5 pi by 2 plus 5, which is 10 minus 5 pi by 2. That's going to be the answer. Question number 12. dy by dx equals to x square. Find the general solution of the differential equation. So dy upon dx equals to xy square. So 1 upon y square dy equals to 1x dx. Apply integral on both sides. Y power negative 1 upon negative 1 equals to x square upon 2 plus c. So what does it becomes? Minus 1 upon y equals to x square upon 2 plus c. So negative 1 upon y equals to x square plus 2c upon 2. So negative y equals to 2 upon x square plus 2c is another constant k. So y equals to negative 2 upon x square plus k. But what else has been given? Y equals to 1, x equals to 1. So the values he has given as y equals to 1, x equals to 1. 1 equals to negative 2 upon 1 plus k. So 1 plus k equals to negative 2, k equals to negative 3. So I get y equals to negative 2 upon x square minus 3, or 2 upon 3 minus x square. The curve has this equation. Find the gradient at C of find the gradient of C at the point 1. Deduce that the line which is tangent to C at a point 1, 1 has equation y equals to x. Find the coordinates of the point where y equal to x meets the curve again. So part C, x equals to 1, y equals to 1. So I will be finding it out, dy by dx. dy by dx equals to how much? What was dy by dx? xy square. 1 times 1 square, which is going to be 1. So part D, equation of a tangent, y minus y1 equals to 1 times x minus x1. It implies y equals to x. Now he says that it meets the curve again. What was the curve? Y equals to 2 upon 3 minus x square. But y equals to x. 2 upon 3 minus x square. So what does that becomes? 3x minus x cube equals to 2. X cube minus 3x plus 2 equals to 0. You factorize it out directly. I'm writing x minus 1 whole square times x plus 2 equals to 0. So x equals to 1 or x equals to negative 2. But x equal to 1 is already used, so our answer is going to be x equals to negative 1. But it meets y equals to x, so y also equals to negative 2. So what's going to be the point? Negative 2 comma negative 2. Question number 13. Use substitution u equals to 1 plus 2x or otherwise to find the value of this one. So u equals to 1 plus 2x. So what do I get it out? Du by dx equals to 2. So du equals to 2 dx. And also x equals to nothing but what? U minus 1 upon 2. So integral of 4x. 4 pull outside, or 4 instead of filling 4 outside, 2 outside, and x upon 1 plus 2x whole square times 2 dx. Now 2 integral of x. X is u minus 1 upon 2 upon u square. 2 dx is nothing but what? Du. So my total answer will become 2 dx is du, and then 2 gets cancels. Integral of u minus 1 upon u square du. So it becomes u upon u square minus 1 upon u square du. So it becomes 1 upon u minus 1 upon u square du. Integral of 1 upon u is ln u, and this will become u power negative 1 upon negative 1 plus c. So it becomes ln u plus 1 upon u plus c. So ln u is 1 plus 2x plus 1 upon 1 plus 2x plus c. Then given that y equals to pi by 4, x equals to 0, solve this differential equation. So 1 plus 2x whole square dy by dx equals to x upon sine square y. So it becomes sine square y dy equals to x upon 1 plus 2x whole square dx. Then what am I going to do? Applying integral. So but the question is, if you see, the first question was 4x, so 4 was missing. So what am I going to do it? Or multiply by 4 on both sides. 4 sine square y. 4 sine square y is nothing but what? 1 minus cos 2y upon 2 dy equals to integral of 4x upon 1 plus x square is nothing but what just now we have done, ln of 1 plus 2x plus 1 upon 1 plus 2x plus c. So this will become 2 times 1, 2 times 2. So 2 times of one integral is y minus cos 2y integral. Cos 2y integral is nothing but what? Sin 2y upon 2 equals to ln of 1 plus 2x plus 1 upon 1 plus 2x plus c. So what does that becomes now? 2y minus sin 2y equals to ln of 1 plus 2x plus 1 upon 1 plus 2x plus c. Now what are the values are given? X equals to 0, y equals to pi by 4. So 2 times of pi by 4 minus sine of 2 times of pi by 4 equals to ln of 1 plus 1 upon 1 plus c. So this gives me, directly I am writing c value pi by 2 minus 2. So what should be my answer? 2y minus sine 2y equals to ln of 1 plus 2x plus 1 upon 1 plus 2x plus pi by 2 minus 2. That's going to be the answer. So going to the next question. The diagram shows the curve with an equation y equals to x e to the power of 2x minus 1 upon 2. Then the finite region R1 and R2 is given. Find the exact values of A1 and A2 and show that A1 upon A2 equals to e minus 2 upon e. That is what he's been asked us to find it out. So I am going to first of all find integral of x e to the power of 2x without the limits. First function, integral of second function, minus integral of derivative of first function, integral of second function. So 1 upon 2 x e to the power of 2x minus 1 upon 2 e power 2x integral is e power 2x upon 2. Now the limits. For finding the limits for the a1 part, the limits are negative 1 upon 2 to 0. So when I do that, negative 1 upon 2 to 0. So when I plug in 0, 0 minus 1 upon 4 times e power 0 minus 1 upon 4 times e power minus 1, then minus 1 upon 4 times e power minus 1. So minus 1 upon 4 times e power minus 1 minus 1 upon 4 times e power minus 1. So what does that becomes? Minus 1 upon 4. Minus times minus is plus 1 upon 4, 1 upon e, plus 1 upon 4, 1 upon e. So what do I get it out? 2 upon 4e minus 1 upon 4. So 1 upon 2e minus 1 upon 4. This is A1, but A1 is nothing but what? In the negative region. So therefore, the total area is going to be negative value of this one. So it's going to be 1 upon 4 minus 1 upon 2e. This is going to be the answer for the A1. So let me write it out A1 in a proper way because we want to get the answer accordingly. So A1 equals to 1 upon 4 minus 1 upon 2e. I take 1 upon 4 common, 1 minus 2 upon e, or 1 upon 4 e minus 2 e minus 2 upon e, or it is e minus 2 up, so we will leave it there. So A1. Now for A2. For A2, what am I going to do? I am going to take the same limits, but the same equation, 1 upon 2 x e to the power of 2x minus 1 upon 4 e to the power of 2x from the limits 0 to 1 upon 2. So plug in 1 upon 4 e power 1, 1 upon 4 e power 1 minus 0 minus 1 upon 4. So it becomes 1 upon 4. Now A1 upon A2, which is 1 upon 4 times e minus 2 upon e divided by 1 upon 4. 1 upon 4, 1 upon 4 gets cancels. E minus 2 upon e, which is e minus 2 is to e. That's going to be the answer. Next, question number 15. Integral of x squared dx, given that y equal to 0, x equals to 0, solve the differential equation. We have to solve the differential equation. For this one, y equal to 0 and x equals to 0. So first of all, first function is x squared, second function is e power negative x. So first function, integral of second function minus integral of derivative of first function, integral of second function. So what does that becomes? Minus x square e power negative x plus 2x e power negative x dx. So once again, this is first function, second function. So x square e power negative x plus 2 first function, integral of second function minus integral of derivative of first, integral of second. So minus x square e power negative x minus 2x e power negative x, then minus integral of, or plus 2 integral of e power negative x dx. So when I do that, minus x square e power negative x minus 2x e power negative x minus 2 e power negative x plus c. Now we have to solve the differential equation. Dy by dx equals to x square e power 3y minus x. So it can be written as dy by dx equals to x square e power 3y times e power minus x. So it becomes e power minus 3y dy equals to x square e power negative x dx. Then e power minus 3y. What is e power minus 3y integral? E power minus 3y upon minus 3 equals to integral of this one. Just now we have found x square e power negative x minus 2x e power negative x minus 2 e power negative x plus c. Now x equals to 0, y equals to 0. So negative 1 upon 3 equals to 0 minus 2 plus c. So which gives me c value as 5 upon 3. So what will be my final answer? 1 upon 3 e power negative 3y equals to minus minus cancels. X square e power negative x plus 2x e power negative x plus 2 e power negative x minus 5 upon 3. Coming to question number 16. The curve with an equation y equals to e power 3x plus 1 meets the line y equals to x at a point h, 8. Find h, giving your answer in terms of natural logarithms. So 8 equals to e power 3x plus 1. So e power 3x equals to 7. Ln e power 3x equals to ln 7. So 3x equals to ln 7. X equals to 1 upon 3 ln 7. Show that the area of the finite region enclosed by the curve y equal to this much and x-axis is this much and x equals to h. So basically, let me draw the graph. It will be somewhere over like this. Then this one was there and x value was 1 upon 3 ln 7, and he is asking us to find it out this particular area. So the lower limit is 0, upper limit is 1 upon 3 ln 7. 1 upon 3 ln 7. Y dx is going to be the area. So 0 to 1 upon 3 ln 7 e power 3x plus 1 dx. So it becomes 1 upon 3 e power 3x plus x from 0 to 1 upon 3 ln 7. Now plug in the upper limit and the lower limit. 1 upon 3 ln e power ln 7 plus 1 upon 3 ln 7 minus 1 upon 3 plus 0. So it becomes 1 upon 3 7 plus ln 7 minus 1 upon 3. So 1 upon 3 7 plus ln 7 minus 1. So what does it becomes? 1 upon 3 6 plus ln 7. So it becomes 2 plus 1 upon 3 ln 7. That's going to be the answer. Question number 17, partial fractions. So x square equals to a times x minus 1 times x plus 1 plus b times x plus 1 plus c times x minus 1. Plug in x equals to 1. So 1 equals to 2b, which gives me b value as 1 upon 2. Plug in x equals to negative 1. 1 equals to negative 2c. c equals to negative 1 upon 2. Then compare the coefficients of x square. 1 equals to a. Then we get the partial fractions and I apply the limits or integrals. 1 plus 1 upon 2 by x minus 1 plus minus 1 upon 2 by x plus 1 dx. Or rather than that, let me write it out another step so that it will be easy for you to understand. He is asking us to do the differential equation. So dx upon dt equals to 2 bracket x square minus 1 upon x square. So what does that becomes? X square upon x square minus 1 dx equals to 2 dt. Then apply integral on both sides. Now this is the partial fractions of the question. That way it will be easy to understand. 1 plus 1 upon 2 upon x minus 1 plus negative 1 minus 2 upon x plus 1 dx equals to 2 dt. So it becomes x plus 1 upon 2 ln x minus 1 minus 1 upon 2 ln x plus 1 equals to 2t plus c. So what am I going to do? X equals to 2, t equals to 1. 2 plus 1 upon 2 ln 1 minus 1 upon 2 ln 3 equals to 2 plus c. This gives me c value as 1 upon 2. It was minus 1 upon 2 ln 3 over there. I plug in 2 and I get it out this one 2. So let me write it out over here. 2 and 2 gets cancels. Rather than simplifying it out in this way, what I will be doing it out is better. I will be simplifying in another easier way, which makes us to get the answer in a proper way, or we can still leave it out over here. We can still do that. 2 and 2 gets cancels, ln 1 is 0 cancels, so C equals to negative 1 upon 2 ln 3 or 1 upon 2 ln 1 upon 3. That negative symbol can be taken away. This is the best way to do. So what is the final answer? X plus 1 upon 2 ln of x minus 1 upon x plus 1 equals to 2t plus 1 upon 2 ln 1 upon 3. This is going to be the answer.